Hello everyone. In this video, I'm going to talk through how to do the calculations for the silver oxide lab. Know that your answers should not be the same as mine because we're going to have different mass values, but your process should be the same. So follow along with me. Make sure you're plugging in your numbers instead of the numbers that I'm putting in, and let's dive into doing these calculations. So jump to the part 15 with this data table, okay? So quick reminder of how this lab worked. We started with an empty crucible, and this crucible had a lid, okay? But really we didn't do the lid part, we just did the crucible. And then I had students, they went and they got the mass. Okay, like they put this empty crucible on the scale, and then that's like the mass that they got for this crucible. Okay? And then we filled this crucible with silver oxide, AgO. But we don't know what the formula of this, like Ag, question mark, O, question mark. Like we don't know what the formula is, but we know we put the silver oxide in there. Okay? And then we went and measured it, and sorry guys, I did this lab with someone. I thought I had the numbers. Okay, it's okay. I know it was like a 40 point, let's do 802. We'll just, that's what, we'll say, okay, we measured it, and that's what we got there, okay? And then what we did is we turned on the Bunsen burner. We put this in the flame of the Bunsen burner, and what happened is that the oxygen left as a gas, as an O2 gas. And so eventually, after heating this for quite a while, what we're left with is the crucible, but now there's only the silver in there because all of the oxygen left. Okay? And so we're going to say maybe for us this was a 40.095. We'll see how my numbers turn out. They might be a little crazy. And then appearance of the product. And so what we saw was that it was started off this really like dark, almost black powder, and it turned into this like white / gray powder. And that powder was all silver. Okay, so that's the idea behind the lab, and I'm going to answer all the calculation questions using these numbers. Again, your numbers are going to be different than my numbers. Okay? So, first thing, calculate the mass of the silver oxide. Like that right there, right? Before we do anything else, calculate the mass of the silver oxide. Well, if I take this first or the second number here, this 40.802 grams, okay? This contained the crucible, the silver in the silver oxide, and the oxygen in the silver oxide, right? That's all of those things. And then if I subtract that from the first number, the 39.921, grams. This is the crucible plus the silver, or sorry, this is just the crucible, empty crucible. And so what we see is the difference between them was the silver and the oxygen, or the silver oxide. Okay? That 40.802 minus 39.921, so it's 0.881 grams. Now, yours should have been closer to 0.5, right? Like I just am picking numbers that I'm working with that I'm hoping will work out well. But yours should have been like really close to 0.5 because that's what you were asked to put inside your crucible. Okay, but I'm going to run with this. So that is the mass of the silver and the oxygen, or this silver oxide. Okay, so I calculated the mass of the silver oxide, and now I need the mass of the silver metal. Okay. Well, this is the mass of the crucible and the silver. Oh, and there's the empty crucible again. So this 40.09, I think 2 is what I chose, or no, 5. That was the crucible and just the silver. And then if I subtract that from the 39.921 grams, that's just the crucible. So then the difference between them would be the silver. .174. I'm sorry, the reason why I'm like pausing in this moment is because I can already tell my numbers are going to be off. So I'm going to change this to yeah, all right, let's try that. I'm going to change this 0 to a 6. I apologize. Right there. And I'll change this one.
How's it going?
It's good. Okay, so then from there, this changed to a 7. Okay, so I took the mass of the crucible with just the silver minus the crucible, and so what I'm left there is mass of the silver. Okay, lovely. So we have calculated the mass of the silver oxide and then the mass of the silver metal. Use the law of conservation of mass to calculate the mass of the oxygen. Well, here's the mass of the silver oxide, so it contains the silver and the oxygen, and there's the mass of just the silver. So if we subtract those final numbers, minus 0.774 grams, then that's the mass of the oxygen. 774. Okay, so that means in that silver oxide there was 0.107 grams of oxygen. All right, now, what is the percent composition of silver and then the percent composition of oxygen in this silver oxide? Reminder, whenever we have the percent of something, in this case, let's start with silver. The percent of silver, your equation is always going to be the mass of the thing, in this case it was silver, divided by the mass total, or the silver oxide. And then to turn it into a percentage, we'd multiply it by 100. So this is the mass of the silver, 0.774, divided by the mass total, the silver oxide, and then I'll times it by 100 to turn it into a percentage. I am working with 3 sig figs on both of those things, and so I'd have 87.9% for the silver. Okay, now the remainder of the percentage should be oxygen because there was only 2 things in there. So you could do 100 minus this to get the oxygen, or you can follow the same process where we do 0.107 grams of oxygen divided by the total of the silver oxide. and then times it by 100 to turn it into a percentage. And so we get our 12.1% that way. So it was, by mass, 87.9% silver and 12.1% oxygen. Now we're going to use the molar mass of silver and oxygen to calculate the number of moles. Again, guys, my numbers should be different than your numbers, and so your percentages will be different than mine. Okay, so just same process but different numbers. So I need to get the number of moles of the silver and number of moles of the oxygen. Let's start with the silver. We have 0.774 grams of silver. Grams of silver, and I want to know how many moles of silver this is. And if I look at my periodic table, I see that silver is 107.87 grams per mole. Okay. So 0.007175 moles of silver. Same idea with the oxygen. I had 0.107 grams of oxygen. And my periodic table tells me that it's 16 grams per mole. .006688 moles of oxygen. Now, sig fig wise, these are both 3 sig figs, so just a heads up, like if this was the free response test, I would do an about 0.00718 for silver, and then for oxygen, I would do 669 moles of oxygen for sig figs. Okay, but I'm going to use my long numbers, my unrounded numbers for part 4. Calculate the ratio between the number of moles of silver and the number of moles of oxygen. Reminder, the best way to find ratios is by taking both of those numbers, so my 0.007175 moles of silver and my 0.006688 moles of oxygen, and dividing both of them by the smaller number. Okay, so when I do this, let me see what I get. So this was 1.072, etc., which is approximately 1, like it's really close to 1. And then this is equal to 1. So I'm getting, for me, a ratio of 1 to 1. That, like, if I were to write this empirical formula, it would just be AgO, and that would be it. So yours easily could be different, like I told you in class. Like the ratio might be a 1 to 1, the ratio might be a 2 to 1, a 4 to 3, like we saw all of those. Like, so I'm okay with whatever you get here, I just want to see that process. So now we're going to write a balanced chemical equation for the decomposition of that silver oxide. So mine is AgO, like a 1 and a 1, but yours could be different. You could have a 2 here, whatever. And it was a solid inside the crucible, and then it broke apart into just the silver solid, and then oxygen, O2, as a gas. Now, because my ratio was 1 to 1, I would have the coefficients of 2, 2, and 1. But again, yours could easily be different, right? Like if you had a subscript of 3 here, then that would completely change it. Like if it was Ag3O, then all of a sudden, we would still need 2 of those, and then this would become a 6 and then a 1, right? So your balanced equation is going to differ depending on what the ratio it was that you got. I'm going to keep working off of this guy, but yes, keep that in mind. The theoretical yield of a product in a chemical reaction is the maximum amount of product that can be obtained assuming 100% conversion of the reactants. So the reactant that we started with here was the silver oxide. And for my fictitious numbers that I used, this was the mass of silver oxide. Now yours was different. Yours should be close to 0.5. Mine was 0.881 grams. 0.881 grams of this AgO, because again, mine's a 1-to-1 ratio. And I know that experimentally, when I ran this in the lab, my experimental yield of silver was 0.774 grams of silver. But what is the theoretical yield? Like theoretically, if I started with this 0.881 grams, if all of that, 100% of that turned into silver, how much silver would that be? And this is our traditional grams to moles to moles to grams, where I'm going to go grams of the silver oxide to moles of the silver oxide, and then moles of the silver oxide to moles of just silver. And then my final step will be moles of silver to grams of silver. This molar mass number, grams per mole, is going to depend on your empirical formula. Mine is 1 silver, 1 oxygen. So when I go to my periodic table, I'm going to add together 1 silver and 1 oxygen. But if yours is Ag3O, then you need to add together 3 silvers and 1 oxygen. So 107.87, 16. So mine is 123.87 grams per mole. Yours could be very different than that. My moles over moles is going to come from my balanced equation. And here I see that for every 2 moles of the silver oxide, I make 2 moles of the silver. Again, this could be different for you if you had a different formula, right? Like here, it would have been a 2 and a 6. These can reduce down if I want it to, or I can leave it just like that, but it could reduce down to 1-to-1 to make my life easier, plugging in the calculator. Now, this is where we're going to be the same, though. We know that for all of us, silver is 107.87 grams per mole, because that's what our periodic table tells us. So now I'm just taking those values, plugging it in my calculator, and I'll see what I get. So I got 0.76723, and then according to sig figs would be about 0.767 grams of silver. That's my theoretical amount. I theoretically, starting with 0.881 grams of silver oxide, I theoretically should have ended with 0.767 grams of silver. So that is our theoretical mass. The actual mass was from your experimental numbers right here. Okay, now, because I just chose numbers like out of the air pretty much, I am going to get a yield that was greater than 100%. This is not impossible in the lab. I could give you some example of errors that this would be the case. One being like that water vapor in the classroom got absorbed into your sample, thinking that the silver then weighed more than it actually did. So it is possible, but it is usually quite unlikely that your percent yield is greater than 100. For those of you that did the lab, I'm hoping to see percent yields that are less than 100. So 0.774 grams for me is my actual yield. Like when I did the lab, that's what I actually got. So I'm doing a 0.774. I'm dividing that grams by my theoretical 0.767. And then I'm going to times it by 100 to turn it into a percent yield. And so this would be, with rounding to 3 sig figs, this would be 101% yield. Okay. If you were in the 90% range, that would be amazing. Last thing. Discuss sources of error in the experiment that might account for percent yield lower or higher than 100%. Be specific. Okay, I'm just going to state some of these, and then you guys pause, write them down as you need to. I told you one. One could be that after you like heated up your sample, then water vapor in the air could have condensed back into your sample, and that would have added to the mass inside the crucible. And we would have thought that was silver when we put it on the scale, and that could give you a higher percentage than 100. One way you could get a lower percentage is if some of the solid splatters out, and you didn't realize that it splattered out. So that could give us a lower percentage. I'm trying to think of other common ones. I mean, yes, there's just human error, like writing down the numbers wrong and things like that, of course. Oh, here's a good one. So occasionally, like a lab will tell you to wash your crucible beforehand and then to heat it up. And the reason why is like we washed it, and let's say we got some water droplets on the side, and they want you to heat it up so that all that water turns into water vapor and leaves, right? But what if we forgot to, or what if we didn't heat it up enough? And so then we have water in there, and then on top of that, we added the silver oxide. Hi, babies. I'm just wrapping up this video. I'm almost done.
I'm so hungry.
So then there's what would leave this crucible would be, yes, the oxygen, but also some water vapor. But we wouldn't know that. We wouldn't know that it was water that left. We would have thought it was oxygen that left. And so we would have had an incorrect, higher amount of oxygen. That's good.
Mama,
It's not your
get
timer.
something from the vending machine?
Go ahead. And so that would give us a lower percent yield for the silver because the oxygen would have been too high. So there's some examples of that. Then go back and fill in this table. So like this is the mass of the silver oxide, the silver and the oxygen. All of those numbers came from question 1. There's the mass of the silver oxide, the silver and the oxygen. The percent for the silver and the oxygen came from question 2. The moles of oxygen in the silver oxide and the moles of silver in the silver oxide came from question 4. The mole ratio, that was question, oh no, sorry, I said question 4 on the last one, that was 3. So this is the percent, and then question 3 is where we got the moles, my bad. And then question 4 is where we got that ratio. Okay. And then the last thing is writing whatever empirical formula you got there. So then you're going to take pictures of these different questions, and you're going to add it to your digital lab notebook. If you've already shared your notebook with me, that's it. Like, you don't have to turn it in again. Like, I already have it. And then I'm going to go in on Friday and check these. If you need more info about the notebook, please go to Canvas, click on Unit 1, and I have a video in there that explains everything with sharing the notebook and adding pictures into the notebook. Okay, everyone, thank you. If you need any extra help, please sign up for a study session, and I'd be happy to help you.